as the atom jumps from the higher energy orbit to the lower energy orbit. Potential energy is minus 2 times the total energy in the ground state. Excitation, absorbing a photon, electron is jumping into a higher energy state. Mass of the earth is 6 into 10 power 24 kg. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. I have been solving problems from the chapter Atoms. Today, in this particular session, I will be solving problems from the same chapter, but prescribed by the NCERT textbook. Most of the problems I solve today are competitive exam based. The first one. What is the shortest wavelength? Umpty number of times, many number of times, we have solved problems from this concept. What is the shortest wavelength present in the Passion series of the spectral lines? Again, we have been asked to calculate the shortest wavelength. What is this shortest wavelength, students? It is the wavelength of the last line of the given series. Shortest wavelength of the last line of the given series. What did we call this also as? We also call this as series limit. Wavelength of the last line of the given series, or series limit of the given series, for which N2 is equal to infinity, and I have to calculate it in case of Passion series, where N1 is 3, N2 now becomes infinity. Now, the same old empirical formula, 1 by lambda is equal to R, 1 by N1 square minus 1 by N2 square. Any number of problems, the moment hydrogen spectrum comes into picture, it is the empirical formula I am referring to. or 1 by lambda is 1.097 into 10 power 7, 1 by 9 minus 1 by infinity, because n2 is infinity, n1 is 3. So on simplification, 1 by lambda turns out to be 1.216 into 10 power 6. But that is not what we have been asked. Idu 1 by lambda agide. Most of the times this is where you lose mark in the last step. You have to calculate lambda, which is 1 divided by 1.216 into 10 power 6, which will be on simplification 820 nanometer. This is the final step of calculation. See, again, one empirical value, how to take N1 and N2. Very easily we arrive at the solution. Next one, students. The problem says a difference of 2.3 electron volt separates two energy levels in an atom. An energy difference of 2.3 electron volt is separating two energy levels in an atom. I have to calculate the frequency of the radiation emitted when the atom transits from the upper level to the lower level. That means as the atom jumps from the higher energy orbit to the lower energy orbit, some radiation, photon has to be given out. I have been asked to calculate the frequency of that radiation. Now, what is the energy difference given to be? So this is 2.3 electron volt. But I have to calculate frequency whose SI unit is hertz, which means I have to convert this energy into joule. So I get E equals 2.3 into 1.6 into 10 power minus 19 joule. I am multiplying by the charge of the electron. Now energy is known. How do I calculate frequency? Do I know a relationship relating energy and frequency? Very good. So we know that energy is equal to h nu. What is h? Planck's constant. Nu, frequency of radiation. So nu is E divided by H. From this expression, manipulating or rearranging, nu is E divided by H. So E is 2.3 into 1.6 into 10 power minus 19, 6.625 into 10 power minus 34, standard value of Planck's constant, we get 5.55 into 10 power 14 hertz. So this is the value of the frequency. Next one, students. The problem says the ground state energy of hydrogen atom. Ground state energy of hydrogen atom is minus 13.6 electron volt. Energy in the ground state of an hydrogen atom is minus 13.6 electron volt. What is the kinetic and potential energies of the electron in this state? So, according to the problem, the ground state energy is minus 13.6 electron volt. I have been asked to calculate the kinetic energy and the potential energy of the electron in the ground state. If it is a 5-mark question, I have got expressions for kinetic energy. I have got expressions for potential energy, substitute and arrive. What if a 1-marker? Or what if it is a question in the competitive exam? So you need to know the relationship between total energy, kinetic energy and potential energy of an electron in the ground state. So first, always remember kinetic energy of an electron. So kinetic energy of an electron in the ground state is minus total energy. Please to know this. Kinetic energy of an electron in the ground state of hydrogen atom is minus K, minus total energy, which means this is minus into minus plus 13.6 electron volt. And the second one, potential energy equals minus 2 times K. Potential energy is minus 2 times the total energy in the ground state, because potential energy of the electron is due to the influence of the nuclear field. Configuration of the nuclear field Therefore, this is minus 2 into 13.6, roughly around minus 27 electron volt. So this is the kinetic energy and this is the potential energy. I want you all to know this relation. If you know this, shortcuts for the entrance exam becomes easier. Kinetic energy minus total energy, potential energy minus 2 times the total energy. The next one, students, this is a sheer assignment for you all. In all my previous 2 sessions, I have worked out problems on this concept. Let us analyze the problem. A hydrogen atom initially in the ground level, n equals 1, ground level, absorbs a photon which excites it to n equals 4 level. Determine the wavelength and frequency of the photon. So initially it is in the ground level, n equals 1. It absorbs a photon, jumps to n equals 4 level. Andre, here it is not de-excitation. Excitation, absorbing a photon, electron is jumping into a higher energy state. Wavelength and frequency of photon. So first, E1, which is minus 13.61 square. You have to summarize because I've clearly done this problem in the previous 2 sessions. E2 minus 13.6 divided by 4 square. E is E1 minus E2. Because here it is not de-excitation, excitation. From the first energy level, it is gone to the second energy level, or I call this E4. So now we know E is hc by lambda, which is E1 minus E4. Once lambda is calculated, frequency nu is c by lambda, where c is the speed of light in vacuum. Same concepts, same methods. Keep on following the sessions, solutions become easy. Next one, the radius of, now he says, radius of the innermost electron orbit. Innermost electron orbit. Innermost andre n is equal to 1 anta artha. Where the innermost orbit is also called as the Bohr orbit. So the radius of innermost electron orbit, first orbit of hydrogen atom, is 5.3 into 10 power minus 11 meter. So this is the radius of the innermost orbit of the hydrogen atom. Bohr orbit. First orbit of the hydrogen atom. What are the radii of n equals 2 and n equals 3 orbits? Now, do we remember the expression for the radius of a stationary orbit of hydrogen atom? Surely yes. Where we told R is n square h square epsilon naught pi m z e square. I have been asked to calculate the radii of the second and the third orbit. Again, substitute n is 2, substitute for all these parameters. Substitute n is 3, again all these things. If it is a 1 marker, all these parameters are constants. Therefore, I can say R is proportional to n square. Consequence, radius of any nth orbit is proportional to the square of the orbit. So R is proportional to n square. Always remember, Rn is equal to n square R1. You can take this to be a shortcut again. Radius of any nth orbit is n square R1. See, for example, he is saying radius of the second orbit, which means R2 is 2 square into 5.3 n square R1. So R2 is 2.12 angstrom. Do I need substitutions and tedious calculations? Simple expression, I have arrived at the result. Similarly, radius of the third orbit, R3 is 3 square into 5.3 into 10 power minus 11, 4.77 angstrom. So if you observe, very simple. Just know these relations that will help you all to calculate. Next one. Radius is 1.5 into 10 power 11. Orbital speed of the Earth is 3 into 10 power 4 meter per second. Mass of the Earth is 6 into 10 power 24 kg. In accordance with Bohr's model, find the quantum number. Quantum number andre n that will characterize Earth's revolution around the sun. Now, from Bohr's atom model, we have mvr is nh by 2 pi. So, I have to calculate n, which will characterize what is called the quantum number. So from here, n is m v r 2 pi divided by h. So substituting for all from the given expression, mass, orbital, velocity, radius, this is 2.5 into 10 power 74, which is practically very, very high and cannot be accepted. So this factor does not ideally give the revolution of the earth. So you can see in today's session how small bit of concepts, relations helps us to solve problems easily. Next, I take up problems from nuclei. Until then, have a nice time. Thank you.